We have a Nordic jumper goes off a ski jump at an angle 10 degree below the horizontal. So it will traveling 108 meter horizontally and 55 meter vertically before landing. So these skier are going to move downward 55 meter and then moving forward 108 meter before it landing. Okay, before it's landing. So the question asks us to calculate the speed needed for the skier on leaving the ramp. Leaving the ramp means is the initial velocity. So we want to find for this initial velocity. Okay, so we understood that as the skier take off actually is doing projectile motions. So what we are going to do is we are going to separate our motion into x and y. So we are going to have x motion and y motion. So starting with the important concept, acceleration along x horizontal is 0. Acceleration along y vertical is negative 9.81 meter per second squared. Then our initial velocity can be resolved into component x and also component y. So we are going to have ux. So this ux is the component that adjacent to the angle. So our ux will be u cos 10 degree. And then we might also have component y, our uy. So our uy will be negative u sine 10 degree. Why negative? Because it is directed downwards. So we write it down. So our ux will be u cos 10 degree. So I calculate cos 10 degree is 0.9848 u. Then I have my uy. My uy will be u sine 10 degree negative. Don't left out the negative because it's directed downwards. So negative, okay. Sine 10 degree is 0.1736 u. Okay, then I have the horizontal distance. The horizontal distance traveled by the skier before it landing is 108 meter. And so 108. Then the skier go down, the skier moving downward vertically 55 meter. So I'm going to have the SY is negative 55 meter. Okay, so what is the final velocity when it's landing is unknown. Okay, so this is only the informations we know for the questions. So we are going to determine the u. So in order to determine the u, I might consider the horizontal component, the x component. So I want to find the u because I know about the s. I can use the second equation. So I'm going to have sx equal to uxt plus half axt squared. Okay, I put in the value. Our horizontal distance is 108. The ux is this one, so I put it in 0.9848 u times t. Okay, the ax is 0, so ax is 0, so I'm going to have equations. So I solve this one. I'm going to have ut is about, okay, so we solve it, 108 divided by 0.9848. 108 divided by 0.9848. So I get 109.67. Okay, I cannot solve it because I have two unknown. It's okay, we put it as equation 1. Then we move on to the component y, the vertical motion. So again, here we have the u that we want to determine, and I know about the sy, so I can use the second equation as well. So we do it again for vertical component y. So uy will be, sy will be uyt plus half ayt squared. So sy will be negative 55. Our uy is negative 0.1736 u. So put it in, negative 0.1736 u multiplied t plus half. Our ay is negative 9.81 t squared. Okay, then what should I do is, okay, here have ut, so I try to put in ut with 109.67, so I replace this one into here. So I'm going to have negative 55 equal to negative 0.1736. So the ut, I'm going to replace with this value. So 109.67 minus 9.81 divided by 2 is 4.905 t squared. Okay, so now I solve for the value of t. So I'm going to obtain my t will be around 2.7 seconds. Okay, so when I get my time, then I can determine, I can substitute it back to this equation, then I can obtain the u. So I put it in, then I'll get my u times 2.7 is 109.67. So I get my u will be around 109.67 divided by 2.7. So I get 40.62 meter per second. So this will be the initial velocity, the speed needed by the skidder on leaving the ramp. Then we have solved question 14.